Ready to go? Okay. Hello, everyone. Thanks for coming. We're going to go ahead and get started on today's session. Click the clicker. So my name's David Stein. I'm a storage business development manager based here on the West Coast. And today's session is going to be about enterprise storage. We're going to be talking about a couple different topics, but the agenda is going to range from a brief overview of all of our storage services to how do I migrate data into AWS, and then we'll focus probably the last half of the session mostly on block and file storage. I'll talk about object storage a little bit in the overview, but the bulk of the session thinking about enterprises and where their data sits today, which is typically on NAS and SAN arrays on premise or direct attached storage that's going to focus a little bit more on block and file options. And so thinking about on-premise storage arrays, it's very different than servers and compute. Servers and compute, you might buy a dozen here or 100 there, and you buy them kind of as needed. But storage arrays are a little bit more complicated to procure, set up, and manage. They have controllers typically with shelves of drives underneath them that require a lot of planning in terms of how much do you need to support in terms of memory and CPU on those controllers, how many disks do I need, how many shelves do I need, what type of connection do I have between them, all the networking that goes with it. And it could take 3 to 6 months or even longer to procure some of these arrays, but they typically stay in your environment for 3 to 5 years, sometimes even longer. It's not unheard of to come across a customer who's going on year 6 and trying to extend their warranty. But you also might get pushed into buying a new array earlier than you thought just because something's end of life. And then you have the CapEx costs that go along with it, as well as the ongoing costs, not just for maintenance, but anytime you need to add shelves of disk or you need to add additional software for additional functionality, those can all add to the complexity of setting up and managing this. And so when we think about how that parlays into storage on AWS, we've got a pretty broad portfolio. We've been doing this for over 10 years, 13 years now, and we really take to heart listening to customers and understanding what kind of technology and protocols they need to be successful, as well as things like performance and features and price to move their data over into AWS and be able to run your applications and databases or whatever it may be on us. And if you look at the portfolio we have today, it kind of follows into 3 general buckets. You have the rehost, or what we'll call lift and shift, and that's going to be your block and file, which we're focusing on today mostly. So this is going to be used for databases, applications, traditional file structures that need a hierarchical directory to host your files in. And you look at companies that are starting to move over to AWS, like LoanLogic or Lionsgate, who look at us and go, okay, well, we need to be able to move this data off of us. We know we have certain types of IOPS or throughputs and capacity, and we just want to be able to fork this over with minimal re-architecting. And then the other side of the fence, you've got what we call replatform. So Storage Gateway is a hybrid service that allows you to offer typical NFS or SAN-type protocols to sync your data into AWS from on-premise. So here's a way to use traditional protocols that you know and love from on-premise and be able to put that into something like an S3 object store where you normally might not be able to put it in right away because your applications don't talk object. And then lastly, we've got the re-architect, which is your object store, right? So here's looking at different types of unstructured data in your environment and go, do I want to re-architect my platform to talk object and take advantage of this low cost and high durability? Or do I want to lift and shift it into something like EFS or an EBS, an EC2 type setup? So these are kind of decisions that you have to think about as you're starting to migrate over to us. And if we look at the journey of what customers take to move into the cloud, there's no set journey. Everybody does something a little bit differently, but very common. We'll see people start with going, okay, well, how do we start with some low-hanging fruit into what we can put into AWS? Backup and restore, backup recovery are usually a good first use case. It's something that is non-disruptive to your environment, and it's easy to set up either using native tools or third-party tools, and allows you to recover without having to build a secondary data center or offsite location and take advantage of the cloud. Next we'll see customers, especially media companies, look at things like Active Archive. So when you have a lot of media files on premise or a lot of tape data that you need to move over to AWS, we have different platforms that work really well with that as well. And then we'll start to look at data lakes. So data lake is a way to take a bunch of disparate data warehouses and databases and move it to a common platform, so you can have a lot of different applications or analytics talk to it without having to run it in isolated areas. So it's about consolidation a lot of times, and taking the data that's in your data center and consolidating it into a single data source. A lot of times this is used for analytics and also offline. But the focus today is going to be more on the last two, which is database and analytics and enterprise applications. So here again, it's probably a little bit more of the lift and shift. So let's take your production databases, let's take your file servers and move them into AWS. And how do we do that? And if we look at how that maps to different AWS services, backup and restore is typically going to use S3 and Glacier, because again, it's a cheap, durable way to get your data into AWS. Storage Gateway is a way to talk to Object Store without having to use the Object Store API directly, and you could use your typical NFS, SMB, iSCSI type protocols. You also have Snow family with the Snowball and EFS as well. Active Archive is going to be typically S3 and Glacier. Data lakes and IoT use a lot of S3, EFS, and Storage Gateway. And then the database and analytics and enterprise applications are going to focus more on EFS, EBS, as well as our native services like Redshift, Dynamo, Aurora, and RDS. So what do you consider when selecting the storage? First, when you're evaluating for a new application, the primary thing to think about is what is going to be the file interface, and how do I map that to a specific service. Second is going to be the features and performance. So here you want to think about what are the features I need with the storage, and what is the performance going to be in terms of throughput and IOPS. And then lastly, you have to balance all of that out with cost, and what's going to make the most sense for your application. And again, this kind of maps back to file, block, and object. So file for your typical hierarchical file data, and then block, which is going to be more just on premise. And so, file is going to be kind of equivalent to your NAS data on premise. Block is going to be more analogous to your SAN data on premise, or sometimes even direct attached storage or local storage on your servers, where you just need a dumb block device to be able to talk to the application. And then you're going to have object, which gives you an API that's internet accessible to be able to talk to your objects in an unstructured way without that file hierarchy. And again, that's going to be EFS, EBS, and S3 and Glacier accordingly. And then if you look at the performance, which is the other thing to think about, block is going to offer the lowest latency. So it's really good for databases, but it doesn't scale to a lot of throughput. So for applications which are typically going to be file data, certain types of data analytics, or media workflows that need higher levels of throughput, then file is going to be the good option there. And then object storage, of course, has the highest amount of throughput, but it comes at the sacrifice of slightly higher latencies than you would get with block storage or file storage. And then the other thing to think about is availability and durability. So different storage platforms on AWS have different architectures. So when you think about the concepts of AWS availability zones and AWS regions, S3 standard, S3 infrequent access, Glacier, and EFS, they all use multiple availability zones. So S3 and Glacier are able to offer 11 nines of durability. So we have very high durability, and this is a very safe place to put your data. But again, the performance on that is going to have slightly higher latencies, so it's not always going to be the best for databases, for example. But it's really good for a lot of unstructured data and data where you can need that high level of durability. And then for other applications, typically going to be on the database side, and then also S3 One Zone, which is a new storage class for S3 we announced this year. That will operate more on a single AZ. So for S3 One Zone, you get a lower cost, with a lot of the same durability and availability numbers that you would get with normal S3. And then EBS, you get that high performance with a single availability zone. And then there's ways you can architect that to make it redundant across availability zones I'll talk here about in the end. So let's talk a little bit about data migration. That's the first thing you want to think about when you migrate the data to the cloud is, how do I migrate? So when you kind of look over the common drivers of migrating to the cloud, saving on CapEx, quicker agility, operational resilience, access to new services that you wouldn't have by on-premise, whether it be some new things around AI or machine learning or different types of services we have in analytics that are new. It's a good way to get the data into the cloud so you can do new and interesting things with it. But the pain points, of course, that you want to consider is, disruption to your application. How fast is it going to be? How much is it going to cost? What are the channels I do to migrate the data over, as well as the compatibility, right? Will this be compatible with the cloud like it is on premises? So AWS, we have a lot of options for data transfer. We've got offline data transfer like Snowmobile and Snowball and Snowball Edge, as well as our new Snowball Edge Compute Optimize. So these are all ways to get your data in bulk. That's kind of more offline. So if you need to transfer a whole bunch of data, but you can handle the disruption to your application, that's a way to go. Storage Gateway is a hybrid one, right? So Storage Gateway is going to allow you to move the data online over to AWS over Direct Connect or VPN, while giving you common interfaces that you know today and be able to store it in S3. Once it's in S3, using Storage Gateway, you can do a bunch of different things with it, right? You've got access to the data in that S3 bucket, and then you could start moving it into different, file or block protocols and wherever you need that data to be, or maybe even some of our native services. And then for online data transfer, we have a couple things. There's actually something new we announced Monday called Data Sync, which I'll talk about here in a minute, and then a managed SFTP service as well. Then you've got real-time things like Kinesis and Kinesis data streams that will stream directly into AWS as well. So Data Sync is a new product we announced yesterday. So this is a managed service that you set up to easily install on a VM on-premise and migrate the data at a much faster rate than you'd be able to do using common scripts and protocols today. So this is designed to get data into S3 or EFS. But after installing a VM on premises and going through a few quick clicks in the console, you'll be able to migrate that data in. So we have developed a protocol around this to enable parallel multi-threading transfer speeds where you should get something up to 10 times what you'd be able to do on premises. And this works bidirectionally as well. So you could set it up to migrate from AWS to your own on-premises arrays, or you could set it up to migrate from on-premises to AWS. But it's easy to use. You don't have to write any scripts. It's just a few quick clicks in the console. It's secure and reliable. It's fully encrypted. It's integrated with CloudWatch, so you could check on metrics. And it's also cost-effective at 4 cents per gig of data copied with no minimum commitments or upfront fees. So use cases that we are seeing with this and expect to see as customers start to adopt it. One is the obvious of migrating on-premises data to AWS. So you could set it and it'll send a full copy, and then it'll start to change and track incremental copies of the data from there. But you might also use it to kind of in a hybrid scenario where you could move data into the cloud for quick analysis. If you don't have enough compute on premises or you want to be able to run a job quickly, you could schedule or maybe you have scheduled jobs where you need to move data into AWS, process, and then move it back out. That's a very common use case. And then replication for business continuity too. So you could send this data into EFS or S3, for backup and DR purposes as well. The point is, again, that not only is it easy and simple to use and cost effective, but you could schedule these things and have it work automatically for you as well. We also announced our AWS Transfer for SFTP. So similar to Data Sync, this is a managed service, so you no longer have to set up and manage your own SFTP servers. So SFTP is something, of course, that customers have been doing for a very long time on premises. It's not something people particularly enjoy doing. So we want to abstract that out and make it easy to use while reducing some of the administrative overhead of having to set this up and manage it yourself. And again, this is also going to be fully managed, simple to use, and very cost effective as well. But what about databases, right? So the first two are kind of like options for getting data into S3 and EFS. But if you have a database to migrate over and you need to be able to cut that over quickly with minimal downtime, you could use our database migration service. So this is a way to migrate your data into a database directly onto AWS and failover. You can also use our schema conversion tool as well. So if you have a database, it's Oracle on premises and you want to migrate it to MySQL or Aurora, you can quickly change the schema design without a whole lot of work and administrative overhead on your part and migrate that over as well. So DMS for database migration service and SCT for schema conversion tool, they're used to modernize your applications. So if you need to move it from a proprietary database to more of an open source one, it's a very common one. It's used to migrate databases over to AWS as well as within AWS if you're doing things like moving between VPCs, et cetera. And then also for replication too. So you could use it to replicate data into AWS for DR type strategy. There's also third-party tools out there as well, so I don't want to limit it to just the AWS offerings. There's very common tools out there like Cloud Endor, Zerto, Veeam that do this very well as well, and I recommend taking a look at those. So let's jump into file storage. So we'll do a handful of slides on this, and then the last half or so will be focused on a lot of the block storage and kind of more databases and applications. So for file storage, we have Amazon Elastic File Store, or EFS. So EFS has been around for a few years, and the idea is if you think about the slide I showed at the beginning about the pain points of managing an on-premises array, EFS has a lot of the same benefits of being able to abstract that out and make it easy to lift and shift your applications. So for IT administrators, what if we could eliminate the file system management and maintenance at scale? But also for your application owners and developers, for this, what if we could lift and shift without having to re-architect any of your code, or enable you to build new cloud-native applications that are highly scalable without having to worry about buying and procuring and setting up infrastructure? And then lastly, for business managers, we make it easy to predict cost, as well as spend less time managing the overhead of setting up your own arrays. So EFS provides simple and scalable storage that's cost-effective and very scalable and elastic. So it makes it easy to migrate without having to handle a lot of the administrative tasks that we mentioned on the previous slide. And if you look at some of the core tenets of EFS, it's elastic and scalable. It's high performance. We have some new storage classes I'll talk about here in a minute. But at its core, it offers shared access. So EFS natively will be allowed to share a file system with hundreds or thousands of different EC2 compute instances within a region. It's also highly available and durable, similar to the S3 model, while also being secure and compliant with encryption of data at rest and in transit. But what we mean by that, so simple, is it's no hardware or filers you have to install. With a few clicks in the console, you can have a file system ready to go. You don't even have to tell us how much storage you want to provision because it's pay for what you use, not what you provision. So the file system's easy to set up. You create a mount target so the instances in your availability zone will be able to talk to the file system. The file system itself is region-wide, so it's highly available and durable within a region, and any file server in any availability zone within that region will be able to access that data. But it's also seamless integration. It's a typical NFS version 4.1 protocol, so it works just like you would expect it to be on-premise. And it's got all the same file system semantics. It's POSIX compliant. It'll work with all your standard OS file system and APIs, all while giving you a simple pricing and forecasting. Since you only pay for what you use and not what you provision, it makes it easy. You don't have to worry about pre-provisioning and growing that as you go. Which brings us to the next point of EFS is elastic. So what we mean by elastic is you don't have to worry about pre-provisioning, but since the data system will just grow and shrink as you add and delete files. So it'll even reduce in size as well. And you only pay for the data you use, so you don't have to pay for anything that you pre-provision. So this makes it very easy to scale your file system up and down for a variety of different use cases without having to predict what that storage amount's going to be or having to go in and scale it as time goes. There's no minimum fee, and you only pay for the storage space that you use. It's also scalable, so we can scale up to petabyte scale. Throughput and IOPS scale automatically as the file system grows. So performance is, there's two types of performance modes I'll talk about. The primary one is going to be the burst model, which is the original model, where your throughput scales linearly as you grow. There's both a baseline throughput as well as a burst throughput. So you can get extra throughput above and beyond what you expect. And that grows linearly. So as you start to add data in, the performance will grow with it without having to think about it. We also now have the option to pre-provision amount of throughput as well if you need a higher level of throughput. But it gives you consistent low latencies regardless of the file system size and support for up to thousands of concurrent NFS connections. So as long as you're spinning up your servers, Linux servers in the availability zone or region where the file system is, our file system will be able to handle it based on the amount of capacity and throughput that you have. And all this being highly durable and available. So since EFS is a region-wide service similar to S3, the service is meant to, be highly available no matter what AZ you're working in. So if you need to spin up servers in a different AZ, you can access the same file system, which gives it a superior availability model to a traditional NAS array, which is typically going to live within a single data center or sometimes up to 2 data centers if you want to use some sort of synchronous type replication between your data centers. But again, you have to set that up and manage the filers and the storage volumes yourself. And the benefit of EFS is you don't really have to worry about all of that, right? We handle the filers, the storage volumes, as well as the replication between availability zones to give you that high level of availability and durability your applications expect without having to set up and manage any of that. So it's really good for production and tier 0 applications. The 2 performance models, and there's also 2 storage classes, which we announced on Monday, or pre-announced anyway. But for performance, like I mentioned, you've got the burst model. So that is a standard amount of throughput per gigabyte you provision, and that'll scale linearly as you add data into your file system and grow it. But we also have a way to provision throughput independently of the capacity. So this is an option to go, okay, well, I need more throughput than I would get based on the file system I have and the bursting and baseline throughput model of the bursting one. So you could provision that separately and get a guaranteed amount of throughput. We also have 2 storage classes for EFS, or we will have 2 storage classes. The primary one, which is going to be higher performance based, and then also the new infrequent access. So if you're familiar with S3 infrequent access, it's got some similar characteristics. But the idea is that if you enable this lifecycle policy in your file system, we'll automatically move data over 30 days into a colder tier where you're going to expect to pay a lot less for it. So you've got up to 85% savings by enabling this. Most file data gets cold very quickly, which is why we developed this. And customers are telling us they wanted a little bit cheaper of a way to put all this older data. So not only do we offer something at a colder tier, which is more cost effective, but we give you an automatic way to set a lifecycle policy so that data can automatically migrate down into that colder tier without you having to fully manage that. So use cases for EFS, it's a wide variety of use cases. It goes across scale out jobs versus metadata intensive jobs. Your scale out jobs are going to need high throughput and a lot of parallel I/O. So we'll see that different analytics workflows, different media workflows, to the other side of the fence, which is low latency and serial I/O for your metadata intensive jobs, which are going to be more home directory user shares and dev tooling. And in the middle, which leans probably a little bit more towards the low latency and serial I/O, but could be high throughput and serial and parallel, is things like enterprise apps that need shared file storage, web serving, CMS, content management, database backups is a very popular use case. So if you're using like a SQL Server or MySQL Server and you want to use native backup tools to send it from EC2 to EFS, this is a great option. that customers will use while storing it for a week or so on EFS while scripting it to then move to S3 for a colder tier. But now with the EFS IA, you could have that automatically migrate to a colder tier within EFS. And then container storage is another popular use case as well. So how does this look? So we've kind of talked about how it's simple, scalable, elastic, it's highly durable and available. This is an architecture of how you would set this up yourself, whether it was on premises or in AWS. As you can see, and I mentioned this earlier, you've got the NFS servers or your filers. You've got your storage volumes you have to set up and provision yourself. And then you have your NFS clients you have to talk to. But in order to make it highly durable and available as a service that we offer, you're also going to have to cross-connect and have these talk between availability zones. So you're setting up a lot of redundant hardware and having to manage that yourself. And really, that's a lot of undifferentiated heavy lifting that you shouldn't have to worry about. Ultimately, what you care about is getting NFS access that's highly durable, available, and simple and easy to use to your application servers or home directories without having to worry about this. So the EFS architecture simplifies this. Most of what you saw at the bottom on the previous screen is simplified by this group of red blocks down at the bottom, which is going to be your EFS file share. And that is a region-wide service. So you could take servers in any availability zone and create a mount target and have that talk to the same EFS share. It doesn't matter what availability zone they're in. They'll all be able to see the exact same data under a single namespace. So we really simplified the architecture, and just, again, a few clicks in the console, you've got the file system up and running without having to go through the complicated setup of managing your own filers and storage volumes and having them talk to each other between availability zones. So next, we'll talk about pricing and TCO. So EFS standard is going to be 30 cents per gig, and the infrequent access is 4.5 cents per gig using US East pricing. So how does that look like per month or set up to work compared to your own installation? If you want to, and this is a very common thing that comes up with customers, we want to make sure we understand the comparison. Because when you're setting up and managing your own servers, you've got to pay for your EC2 resources, you have to pay for your EBS volumes, you have to pay for the inter-AZ data transfer cost. So just to create a dual AZ architecture to create something highly available, you'd be looking at $599 per month for a 600 gig volume, plus the administrative overhead of having to set this up and manage it. Since EFS is 30 cents per gig, sorry, it's a 500 gig data store, but you would over-provision by setting up your own, right? Because when you set up your EBS volumes, you need to create a provision capacity. And 600 gigs is probably conservative. You might even go 700, 800, or up to a terabyte. With EFS, it's simple. At 30 cents per gig times 500 gigs per month, you're at $150 per month compared to the $599 of setting this up yourself. Even if you didn't care about the durability and you didn't want a dual AZ setup, you're still looking at 60 per month on the compute, 170-ish on the storage, plus, and even if you take out that data transfer cost, you're still pretty comparable, again, while having your own administrative overhead of setting this up and managing it yourself and keeping it up and running. So this is a list of EFS customers using us today. So you've got Digital Relab. They're using us for containers and serverless environment. They were able to save 43% while scaling performance and saving on idle compute with zero refactoring. You've got Celgene, which is using us for genomics. They were able to speed their time to market and help their patients faster by using EFS. Reuters is another company. They do content serving and websites. They save $10,000 a month on their bill by moving to EFS because they only pay for what they use. They don't have to provision the storage and the server volumes to manage this themselves, nor do they have to worry about running out of space or bandwidth. So they can just grow and scale as they add data without having to manage that aspect. So for the rest of the session, we're going to focus on block storage, as this tends to take up the bulk of customers' environments on premises with applications and databases. We do have, I forgot to mention this earlier, but we don't cover a lot of S3 and object storage in here. For data lakes, Active Archive, things like that, like we mentioned at the beginning, we have a handful of different sessions here talking about that. But since most enterprise storage tends to be on block and file on premises, and we want to look at the initial lift and shift into AWS, which is a common migration approach, EFS and EBS provide the easiest way to do that. We'll typically see customers lift and shift and then start to re-architect. And to kind of harp on that a little bit, We've got native services, right? So what you have to think about when you start to migrate these applications over to us is, do I want to go straight into EC2 or EBS, or take advantage of native services? We recommend looking at native services first, because they take out the administrative overhead of having to set up and manage this. RDS abstracts away the having to set up and manage your database servers. Aurora and Dynamo for SQL and NoSQL databases, they even abstract the need to set up your volumes. So kind of like EFS, how it simplifies storage by just allowing you to put storage into your platform without worrying about scaling and provisioning and performance. Both of those work similarly while also leveraging multiple availability zones. So they're very good services to use. And since Aurora and RDS or Aurora anyway is based on MySQL or Postgres, it should be very similar to any SQL or Postgres servers you have. If you have Oracle on premises or SQL Server, RDS makes it easy so you don't have to worry about managing the databases. But even data warehousing, right? If you have a Vertica or Teradata data warehouse you want to move over to us, Amazon Redshift makes this very easy as well. From a MapReduce and Hadoop standpoint, if you're using Cloudera, Hortonworks, or MapR, Amazon EMR is a very good choice, and then EFS as well. And so what you think about is with those databases is, and as you're moving over, is if you can't lift and shift it for some reason, and there's a few reasons why people can't move it into the services, and you do want to lift and shift it and use the same protocols, then you would want to use EC2 and EBS. And that's what the rest of this session is going to be focused on. We don't talk a whole lot about the other services, mostly because they abstract the need to set up and manage your storage. But for EBS, and a lot of what I talk here is going to be applicable for RDS as well. So RDS uses similar mechanisms which make it relatable as well. But Amazon EBS, we make it still transparent, reliable, and performant. So transparent, you have minimal re-architecting for applications. You can lift it and shift it without having to worry about re-architecting, and you can adjust performance and price on the fly with our elastic volumes. It's also highly available and failure tolerant. So we handle replication behind the scenes with EBS, so you don't have to, which is foundational for enterprise applications, and then also performant. So you get a lot of throughput and IOPS, which is dependent on what types of volumes you use, and I'll kind of go over into that as well. So if we look at all of our block storage offerings, it's not just EBS. We have EC2 Instance Store with the i3s and H1 instance types. You've got EBS SSD-backed volumes, so GP2 and IO1 are general purpose and IO1 volumes. And then you have HDD-backed volumes. So that's going to be your ST1 and SC1 volumes. So Amazon EC2 Instance Store, the big difference here is that it's local to the instance, so it's fast, right? You can deploy an i3 and get millions of IOPS and very high throughput, but it's not persistent to the data store. So every time you stop and restart your instance, that data disappears unless you're backing it up. It's not replicated, so it's just a single copy, and there's no built-in snapshot support or SSD or HDD. So this is important to consider, even if you have applications that don't care about redundancy, because they handle it at the node layer. You see this with NoSQL databases like Cassandra or Mongo. You see it with different data analytics tools. We still see customers using EBS, which is not something they would typically do on premises. With those types of applications, you wouldn't use SAN storage. But when you move to the cloud, the story changes a little bit because you lose that data persistence. And every time you stop and restart that instance, that data is no longer there. And it could take hours or days sometimes to build new nodes in a cluster for a Cassandra cluster, for example. But you also, customers really want that snapshot support to make it easy to back up. They also want the built-in encryption as well that you've got with it. So EBS, the volume persists independently of EC2. So it makes it easy to right scale or right size your environment. So you could pick the compute based on the CPU and memory that you need, and then size the storage completely independently. So this allows you to scale your storage as you go without necessarily having to bump up into a higher EC2 instance than you might not normally need. You could detach and reattach between instances within the same availability zone, so it makes it very portable as well. So EBS, it is a one-to-one mapping on the volume side anyway to the instances. So an EBS volume can attach to one instance, but you can attach multiple EBS volumes to a single instance. People do that for a variety of use cases. You have boot volumes, data volumes, and different types of data volumes, so you might need to attach it. Similar to how you do on premises by creating different volumes, you would just create different volumes here, attach, or different LUNs, I would say, but on AWS you create different volumes and attach it to the instances. So this allows you to separate volumes and get different performance characteristics. So the benefits here, again, it's going to be persistent, so you can stop and restart the instance, detach the volumes without losing any of the data. It's elastic as well, so EBS elastic volumes allows you to change volume types live without taking your volume offline, as well as change your capacity by scaling up and changing performance on our provisioned IOPS volumes. So if you're lift and shifting into the cloud and you're not sure what type of volume you need, we'll go into this in a few slides, but it makes it easy to adjust that on the fly as you go. It's highly available, so we're designed for 5 nines of availability. Durability, which is not something that most on-premise SAN vendors, word durability around. It's typically just around availability. So AWS EBS, Amazon EBS is 0.1 to 0.2% annual failure rate on the durability. What that translates to is if you have 1,000 volumes in your environment, you could expect to lose 1 or 2 per year. So you want to use EBS snapshots or backup mechanisms or some sort of high availability or durability to create an NHA structure if you needed something more than that. And then secure, so we support encryption at rest and encryption in transit for all EBS volumes as well. So we talked earlier about the SSD and HDD buckets. So on the SSD side, you have general purpose SSD volumes and IO1 provisioned IOPS. And then on the HDD side, you've got ST1 and SC1. T is for throughput and C is for cold, but I wouldn't worry too much about what the names mean because a lot of the ones or volumes or way customers we see use these volumes is that the cold volumes work very well for a variety of applications. So I hate to use the word cold because it actually does perform very well. But how does that map to different use cases? So relational, on the SSD side, databases and different types of non-relational databases are a very good fit. So anything using random I/O, really, which is going to be databases. On the HDD side, it's designed more for sequential and throughput-driven workloads. So whereas SSD is really good for random I/O, HDD is good for sequential I/O. And this is going to be, I should have asterisks on most of these, but Kafka, Splunk, Hadoop, data warehousing, these could go either way. And we see a variety of different architectures that use sometimes all HDD, ST1 and SC1 volumes. Sometimes they use a hybrid of volumes as well. And then media storage as well, which is throughput driven, and sequential, which is really good for HDD. So when you think about, what volumes you're going to use, to kind of break that down further, general purpose is a really good all-rounder type volume. But when you have SSD volumes and you have to think about what's going to be a better fit for your volume, should I use GP2 or IO1? A lot of it comes down to performance consistency. So provision IOPS allows you to provision your IOPS independently. We announced this the other day, but you can now provision, I think, up to 64,000 IOPS per volume. So you can get a lot of throughput and up to 1 gigabyte per second of throughput. So you can get a lot of IOPS and throughput with the volume. But GP2, sometimes you can do that together by striping together multiple volumes. And in some aspects, it's a math problem of how many GP2 volumes do I want to set up and manage versus a single IO1 volume. But the other thing we really encourage people to look at is performance consistency. So IO1 has a performance consistency of within 10% of your provision performance, 99.9% of the time. GP2 is 99% of the time. So it's a small difference. But if your applications are up 24/7 and they are sensitive to those types of performance characteristics, you definitely want to stick with IO1. It's going to give you a better performance consistency for your applications that need to be running 24/7 and are in production. If not, GP2 is a really good fit for most other workloads. You can use it for a variety of different things and adjust it, as you go. And it has a linear scale of throughput and IOPS per gigabyte. And then for throughput driven, you've got ST1 and SC1. Those work very similarly. It's just a matter of how much throughput do I want. And then you have EBS snapshots as well. And so that's something that you want to make sure you leverage for backing up your data that I'll go into here in a few minutes. So when thinking about what EBS volume I'm going to use, the question you have to ask is what is more important to my workload? Is it IOPS or is it going to be throughput? For IOPS-driven workloads, again, you want to choose between GP2 or IO1. And that's going to largely depend on the performance consistency characteristics you want, as well as how much max IOPS you want. Again, with IO1 going up to 64,000 IOPS and 1 gig per second of throughput, whereas GP2 can go up to 10,000 IOPS and I think 160 megabytes per second of throughput. You could, again, stripe together multiple GP2 volumes using a RAID 0 to aggregate that, or you could use a single IO1 volume. And again, that's going to come down to management overhead and then that performance consistency question. So from a pricing standpoint, in your SSD, you've got 10 cents per gig US East pricing on GP2. IO1 is 12.5 cents per gig plus 6.5 cents per provisioned IOPS. ST1 is 4.5 cents per gig, and SC1 is 2.5 cents per gig. So there's a wide array of price points depending on what your application is. And kind of what I mentioned earlier on the SC1 volumes, you don't want to think about it just in terms of cold storage. I don't have performance characteristics on here. You could view it on our website. But SC1 offers up to 250 megabytes per second. So if you have a throughput-driven workload that's sequential, that fits within that, it actually gives you more throughput than even GP2. It's not going to be good for small random I/O applications like databases. But if it's throughput-driven, you're actually going to get better performance out of SC1 at a quarter of the price. So it's important to think about, again, is that application going to be IOPS-driven or is it going to be throughput-driven? Because you want to make sure you're paying for the right volume and getting the best cost per performance on your volumes. Cheaper doesn't mean less performance. It really depends on what your application is driving. And then we have snapshot storage, which is 5 cents per gig on all volumes. And I'll talk about that in a minute. So a couple best practices I'll talk about here that we see as a common pattern with customers that start to migrate enterprise applications to us that we want to make sure is kind of communicated here and you guys are able to think about as you migrate applications over. One is EBS optimized. So EBS optimized is a shared network pipe between your EC2 instances and an EBS volume. It used to be you had to select this as a checkbox when you launched your instances. I don't know if there's any instances left that you still have to do that for. I think almost all new instance types, it's automatic. So what this offers is before, you would have to share your EBS traffic with your S3 traffic, other EC2 instances, all your internet traffic, which would compete for throughput. EBS Optimized gives you a dedicated pipe. So in this instance, we're using a C42XL, which gives you a dedicated pipe of 125 megabytes per second. So it's dedicated network bandwidth. You can actually provision up to 80,000 IOPS and almost 2 gigabytes per second of throughput by using EBS optimized instances. It's enabled default on most generation instances as well. So let me give you an example of why this is important. So in this case, we have a C4 large, and I apologize, we're on the C5s now, so this is a little bit older. We have a C4 large, which can push up to 4,000 IOPS. But if you provisioned 2 GP2 volumes, you're expecting to get 6,000 IOPS, you're actually going to have a bottleneck here. So you want to make sure that when you pick you pick your EC2 instance, you're picking something that's got the right throughput. I don't have the chart here, but if you Google, I think like EBS throughput optimize or something like that, you'll get a chart on our documentation that shows what each instance type can do. But you don't want your instance to be the bottleneck. So in this case, this wouldn't work, right? You would have that bottleneck. But if you provision one size up on the instance, 2XL, that could support up to 8,000 IOPS. So now your 6,000 expected IOPS from your EBS volume would be able to work, and you would actually have some overhead with that as well. There's a caveat here as well. So a lot of the new instance types have throughput bursting. So you can do like a C5 large, which can burst up the throughput of what a C5 4XL can do. So that'll allow you to burst without having to provision more CPU and memory than you might need. So you have a couple options on that, but again, really pay attention to what EC2 instance you're using is compared to what your expected IOPS is. Another best practice that comes up is when to RAID. So I mentioned striping together GP2 volumes to get aggregate throughput. And in that previous example, there was 2 volumes striped to get 6,000 IOPS. Typically, if customers have, so there's a couple things. There's storage capacity. Each EBS volume can provision up to 16 terabytes. And then the max amount of IOPS a volume can do is, well, it's now 64,000 on IO1. It's 10,000 on GP2. And then throughput as well. So an instance I mentioned can do 80,000 IOPS. So what if you're using GP2 and you need to get that 80,000 IOPS? You would stripe together 8 GP2 volumes in a RAID 0. And that will give you the aggregate throughput and IOPS to your instance. But what you don't want to do is RAID for redundancy. So on premises, you're very commonly setting up a RAID 1, a RAID 5, or a RAID 10 to create redundancy. But with a service, we replicate the data already behind the scenes. So you don't have to worry about that replication. If you're doing a RAID 1, for example, it's going to halve your bandwidth. It's going to, you're going to have to provision twice the amount of storage. And the other thing is that we can't really guarantee where those volumes are. EBS as a service, when you provision a volume, we've got placement logic that keeps the volumes close enough together to get the best performance while far enough apart to reduce any blast radius, disk fail, and all the time. And we make that transparent to you as a service by keeping your EBS volume up and running, and while being able to handle all those as a service in the background. If you do RAID on top of that, it happens at the OS level, and we can't see the OS. So we don't really know where that is, and we can't guarantee that's going to be on separate hardware. So it doesn't really always give you the redundancy that you hope. And again, it's doubling your storage costs and having your bandwidth. So we don't recommend doing it for redundancy. Let's talk about keeping your data protected. So with EBS snapshots, you've got the ability to store the data on S3 for long-term durability. So S3's got 11 nines of durability. It's spread across 3 AZs. And so EBS snapshots are going to take point-in-time copies and send it to S3. Each snapshot after the first is incremental, so you're only copying changes as they occur, so it's very cost-effective. And they're crash consistent as well. So you could take snapshots regularly. You could schedule them with our lifecycle manager, or you could issue your own API calls to take snapshots. And now that it's in S3, you could quickly restore into a different availability zone, or you can even copy your snapshots between regions as well, and restore it into instances in different AZs or different regions. So not only does it provide a long-term, cost-effective, durable backup for your data, but it allows you to spin up instances quickly in other availability zones or other regions. And one thing I forgot to mention earlier is Storage Gateway, our hybrid product, also allows you to store on-premise data as an EBS snapshot, so you could quickly rehydrate into an EBS volume as a data migration or a backup mechanism. So I'm going to go over 3 quick architectures just to give you an idea of how this looks and translates into real-world examples. First, we'll talk about Oracle, then we'll talk a little bit about SAP HANA, and then we'll talk about SQL Server and Windows environments. So Oracle databases on AWS, you could set it up and manage it yourself, which requires a lot of administrative overhead. You could set it up on EC2, I mean, or you could set it up on RDS, which abstracts the need to set up and manage the database server itself. We recommend RDS where you can, but for various reasons, we'll see people still install it on EC2 and EBS. So we want to talk about some of the best practices with that. So a lot of this kind of ties back to what I was talking about with the EBS optimized, as well as the multiple volume scenario. So here we have a 6 terabyte Oracle database that needs 40,000 IOPS and 640 megabytes per second. So in this instance, we set up an R416XL. We set that up because it could push 75,000 IOPS. And we've got multiple volumes underneath the scenes. We have our root volume, which is 20 gig. We've got our logs volume, which is 100 gig. Both of those are on GP2 volumes. But our data has a much higher performance characteristics. So we need that on IO1, and we need a higher performance consistency guarantee. So we use Oracle ASM to stripe across 2 volumes because we can't, as of before Monday anyway, you can only do up to 32,000 IOPS. You can now do 64,000. So you could actually use a single IO1 volume today, but when I created this architecture with the 32,000 limit, we needed 2 volumes. So we created 2 3 terabyte volumes, each with 20,000 IOPS to get 40,000 IOPS. and stripe that together using the Oracle ASM. And then you want to make sure you back up the data. So you could use a fast recovery area is one thing that's commonly used. So if you look at that ST202 terabyte volume, there's a couple ways to send your backup. I mentioned earlier EFS. So EFS is a great place to store your backups. ST1 volumes are really good for that. And we have people using Storage Gateway as well. So there's a couple places to put your backups, but that fast recovery area lets you keep a point-in-time copy for your first 7 days. And then you could send data to S3 for long-term backup using RMAN. So here's a great way to back up your data and keep something fast, hot, and local for quick backups, or long-term for the higher durability that you've got with S3. And we've got, I did this presentation last in Berlin, so we've got EU Central as the examples here, but it should be irrelevant. HA and DR is something else to think about. So you've got highly available architectures within the availability zone on EBS. As I mentioned, as a service, we handle that replication underneath the scenes. But let's say you need to have high availability between AZs or different data centers, right? You could use multi-AZ replication by using DataGuard, which is very common for Oracle environments. There's third-party software out there as well, but DataGuard is very common. So you can replicate between AZs for high availability, or you can replicate between regions as well for DR. Of course, regions are going to have a slightly higher latency, replicating to it, but that's a really good DR strategy as well. And here's a big architecture slide. This is a little bit of an eyesore, so apologies, but this kind of ties everything together. So it's got your single AZ with your different root logs and stripe data volumes attached to your Oracle DB instance, sending RMAN backups to S3 while using DataGuard between availability zones. And then we use a DR strategy to a different region as well. So next we'll talk about SAP HANA. So SAP mandates specific KPIs for HANA and log volumes. So you want to make sure that you've got a certain level of throughput and performance. You've got minimum 400 megs per second, excuse me, on HANA data. You've got minimum 250 megabytes per second on log data, a low latency on the log, but both IO1 and GP2 volumes are certified. So in this instance, we've got an X1. X1 is optimized for HANA workloads. As an in-memory database, it can hold up to 4 terabytes of memory, at least on the X1 when I created this slide. So that allows you to store your data in memory, but you also have EBS volumes for root, binaries, shared, and log volumes, backup, stage. So you've got a variety of different volumes you could use here. And again, it's just picking that best volume for price and performance. So it's a mix of GP2, IO1, and even ST1s in this environment. So when to use IO1 or GP2? Again, this comes down to throughput. And this is before our announcement of higher throughput and IOPS on IO1 volumes. But as you're moving the data to EBS, an IO1 with 3 1600 gigabyte volumes can do it with that 1500 megabytes per second. And that's actually going to be twice that with the new improvements we made. But it would take 23 minutes versus a GP2, which has a lower throughput amount. And that would take over an hour to load the data up from a data store into your in-memory. So those are something to think about when choosing different volume types. It's not just the throughput and IOPS and performance consistency, but on the throughput level, it's how fast can I move this data in and out of the volume. And elasticity as well. So as you look at migrating environments, sometimes people will start with an R4, then move to an X1. Similarly with the EBS volumes, you can use elastic volumes to grow from a smaller volume size to a larger volume time to make it easy to scale your data as you grow. And with EBS, there's no need to take the volume offline, just on the instance size. And then we have a quick start guide that covers a lot of this as well. So if you're familiar with our quick starts, it's a great place to get started and look at some simple architectures that incorporate a lot of what we talked about today. And we have a variety of SAP workloads on AWS across the board. I'll kind of skip through this for time so we can cover the EBS or the Windows piece. So Windows, the last piece we'll talk about today. So you have the option of SQL Server deploying on EC2 or RDS. Similar story, right? RDS abstracts the need to set up and run and manage your own database and perform patches and updates. But customers that still choose to run it on EC2, we want to cover some of the best practices with it. So multi-AZ SQL Server on Amazon RDS. You've got always-on availability groups. So within a region, a lot of the same things we talked about with Oracle and SAP apply. In creating your log volumes, your root volumes, your data volumes, striping together, making sure you've got the right instance size for throughput, et cetera. So I'm going to skip over that part, but if we think about high availability and disaster recovery, always-on availability groups, with RDS, you don't have to worry about it, right? You could click a checkbox when you launch the instance, and we'll handle replication between availability zones for you as a service. If you want to do it yourself, you could set up always-on availability groups between AZs. So that's a synchronous commit and provides automatic failover between availability zones for that high availability. And then between region, we can do asynchronous copies as well. So that'll keep a DR copy in a region, away from your primary region through VPN. Last thing we'll talk about is best practices on snapshots. Snapshots, we introduced capability to take VSS-aware snapshots last year through run instance command. So VSS is kind of more of an application-consistent snapshot that will flush and key the database. So it's in the state, and any I/O in flight is protected. So it's simple. I put new, but this is a year old at this point, but not a lot of customers are aware of it. But when you're taking an EBS snapshot, you could use a policy generator to create an IAM policy. Put your action and create your Amazon EC2 type for the IAM role and attach to your instance. Call the run command, AWS EC2-create VSS snapshot. Select the instance that you want to put that through, add the description and tags, run the command, and that'll flush the I/O and freeze the database and take the snapshot for you. So there's multiple ways to do this. In the past, customers would use third-party tools or just issue the command themselves. But by doing it through run instances, it makes it a lot easier so you can simplify some of the commands and process with that. And with that, that's kind of it. As far as thinking about what we went over today with migrating the data and choosing, block versus file, within block, what are the best types of volumes for my environment? Hopefully that was useful. We continue to listen to your feedback and innovate on ways to make this easier. But the goal is we want to be able to have you lift and shift your application seamlessly into AWS and know and use a lot of the same tools that you use on premises. So I'll be up here for the next 5-10 minutes. And if you guys have questions, feel free to stop by. Otherwise, thank you for coming.